All right, I think it's live, and I think it's recording audio. I see little green lights. I'm gonna give. Okay, it says I'm live. Okay, hello. I am Jason, and I am doing a live stream of my video series, "How to Make an Alexa Skill with Python." This is I think an 8-part series. This is my first time doing a live stream, so hopefully I don't. Hopefully, don't do anything terrible. I have the chat window open, so if you have any questions, I am here, and let's all hope I can answer those questions. Okay, so let me just get a quick drink here, and we'll jump right into it. Okay, we're gonna go right into part 1 here. This is the introduction. So hopefully you have played with one of these little devices. It's generally what we've got here is the Amazon Echo Dot in the picture. Hopefully it'll help you a lot in this video, or if you watch other series, to have played with some of them so you kind of know how the interactions work. We'll get into a little bit of it, but it's a little hard to conceptualize it when it's very abstract. So if you have some problems, maybe play with the device if you can. And there's a simulator you can use, but we'll get to there. So from the very beginning, it's important to remember that there is the Amazon Echo, and you have a little dot, the little guy like this, kind of like a hockey puck. There's the original one that's a little bit taller, and they have a couple of other devices. And then there's the Amazon Alexa. The Amazon Alexa service system is an intelligent personal assistant developed by Amazon. So there's Alexa devices like the Echo, Echo Dot, Echo Show, and Fire TV. And then there's the Amazon Alexa devices. There's other things that are coming out that are running that Alexa software or hooking into that Alexa service. Things from lamps, DVRs, cars, trucks, refrigerators. So it's important to remember these are two related, but not the same thing. So when you're developing these Alexa skills, they're not just for the little dot or the little tower. At some point in the future, we're probably going to be seeing this all over the place. This is kind of that concept of the ambient computing. Alexa skills, they add features. A good analogy can be made between Alexa skills and apps. So you're adding features. This tutorial series will teach you how to make these skills with Python. This is part 1. Basic requirements are that you have a basic understanding of Python and you already have an Amazon Web Service account set up. Recommendation is to have an Echo or a Dot so you can kind of play with it, so you can get, like I said, so you can kind of get the feel for it. An alternative would be to go to this website, this echosim.io, and it'll kind of give you the feel of it, but it really doesn't. It doesn't compare really. The device is kind of, I don't want to overdo it, but it's a bit magical. So you really having the device in your home and interacting with it, you get a whole different feel, and it will really help you. Aside from the technical aspects of developing those skills, it'll help you in just the conceptual ideas of like, oh, what skills could be useful. If you go in the App Store, you'll see a lot of the skills. The skills page for installing skills for your device. You'll see a lot of skills that maybe it seem like a good idea, but when you actually use it, it's not. So, but I'm getting off track here. We'll go. So, try to get yourself one of these little devices, and the Echo Dot is only like $40. I think it's a pretty cheap little device for something that's pretty fun. All right, so. Infrastructure we're going to be using is the AWS Lambda. It's a serverless compute. You can develop Alexa skills with like Flask and other kinds of services where you're building your own websites, but it's hard to beat the AWS Lambda infrastructure for this project because you don't need to be maintaining any servers. You basically just throw your code up onto their servers and they handle it all for you. It's pretty sweet. Okay, JSON everywhere. Almost everything you're going to be dealing with is JSON. Those JSON objects will be represented by Python dictionary. So keep that in mind. There's going to be dictionaries within dictionaries. For as far as the eye can see, I'm going to be trying to assign some of those dictionaries to variables just to shorten their length. Because for me, and I think for a lot of other people, it gets very confusing when you see like a lot of nested dictionaries. It's hard to remember where they go. Okay, so this is just a quick little example. So what happens is there'll be requests and responses coming back. Is very much like an analogy to a sort of a web server. So his is like this is just for a visual. This is don't worry about what all this stuff means. But this is just kind of what the request comes in. It's going to come into your Lambda. I was going to say server, but it's your Lambda. Your Lambda. I'm just going to say your Lambda, and then it will process this, and then it will do what you have told it to do. And this is a quick little example of response. Once again, don't worry about what the screen here is. That it can be cryptic, but you can see it is, standard JSON, and it's a lot of nested dictionaries or nested objects. See, I'm already going into the dictionaries because I know where we're going. So, okay, essential ideas. We've got wake words. This is the word that Alexa is waiting for. Also, I apologize. I should have warned you. The beginning is to maybe unplug your Alexa or put it in the other room, because I've been saying that word so much, it's probably been responding over and over again, and you hate me. So sorry about that. This is a wake word. So when it hears this word, it starts up. I believe, well, Alexa is the main one, but also I believe you can say echo and just computer, and that will wake it up, and you'll see that little ring light up and mean it's waiting for interaction. Invocation name is the name you use to access a skill. So an example would be Alexa, open daily numerology. Alexa, give me my daily numerology. Alexa, ask numerology about the number 23. Daily numerology would be the invocation name that you'd be using there. Hopefully that makes sense. It's so everything you're doing with this Alexa, this is why it's important to kind of have one or play with one. It's all through, you talk to it. So we have to think about things and how you interact with the device when you just talk to it. Intent is what the user wants to accomplish. They may say it in different ways, but the intent is the same. Alexa, ask daily numerology about the number 13. Alexa, ask daily numerology about if 13 is lucky. Alexa, ask daily numerology 13. The user wants to know about the number 13, and they're asking that the daily numerology skill to tell it about number 13. So it's our job to kind of design some of these intents. Slots. And once again, don't worry. These, hopefully I said it earlier, I may have skipped over it. I'm just trying to give you some essential ideas. We're going to dig deeper into each one of these things, but I want to make sure these contexts or these ideas have context. So slots, they're a bit like variables. So we're going to go, Alexa, ask daily numerology if 13 is lucky. Alexa, ask daily numerology if number is lucky. You can see here, hopefully, I don't know if you can see my mouse on your screen. Oh, you can. It's very slow though. 13 is kind of a variable. Not a kind of variable, it is a variable. And this is an example of how you would write it out in these slots. Think of it, the way it's been described a lot is like Mad Libs, right? So ask daily numerology if blank is lucky, and then whatever fills in that blank is going to be given to you. We would have, so you're going to be passing that information to your Lambda function. Sessions are a series of interactions with a shared memory. The biggest analogy I can give you, or not the biggest, the best analogy I could possibly give you might be something like a browser cookie, like a session browser cookie. Like it's only there while the browser is open. If you close it, it goes away. This is it. That's like the short-term memory of the Alexa. Response. A response is going to be in two parts. So when you're interacting with Alexa, you're going to be writing response. It's going to be a speech part and a card part. So the speech part is what Alexa actually says to you, and the card part is kind of a graphical representation of what Alexa has set to you. And that's going to be available in there's a couple GUI interfaces for Alexa. There's an app, and there's also a website you can go to. And so all of your interactions with Alexa will leave these cards behind, so you can kind of go back in time and see what you need to see. It also allows you to do certain things like, I'm trying to remember what it was called. It was certain permissions. The permission I ran into previously was location. And so that location permission, you couldn't actually get it vocally. You had to send a card to the person and their graphical user interface, and then they had to use that card to allow location. But it's a bit beyond the scope of this this video, but maybe we'll do a video later that covers asking users for their location. Okay, we've entered the end of part 1 already. So I'm going to minimize this, and we're going to go to part 2. I don't think we have any questions, so that's good. I mean, we don't have any viewers either, but that's okay. So how to make an Alexa skill with Python part 2. Setting up a new Alexa skill and Lambda function. Right, so you're going to log into the AWS Management Console. The links are going to be in the description of this video in case you need them, but if you already had an account, you probably already know where to go. Search for the Lambda service. If you are like me and you use Lambda functions frequently, it will be right there waiting for you. Yes, I guess I went too fast there. There's a little panel here that, well, there's a search. You can put Lambda in there, but also, like if you have recently used services, it'll be right there. If you don't see it in the recently used services, just put in Lambda and it will pop up for you. You want to make sure your region is set to US East, North Virginia, and that's going to be up in the upper right-hand corner. You pop that down. So they changed this recently. I actually didn't check today to see if they changed it again. You are going, once you're in the Lambda function, you're going to, once you go back, oh no, I've messed it up. All right, we're going to go back. Once you click on that Lambda, it will, a Lambda link, it was going to take you to this screen. We're going to select your blueprints. And these are kind of like your templates for making these Lambda functions. We're going to select author from scratch. They used to have some templates that were good for Python, but last time I checked, they would disappeared. That might not still be the case. Okay, so if you're not familiar with Lambda, or the AWS Lambda, it's essentially you give them a chunk of code and they run it for you. In order to make that work, you have to have some kind of trigger, right? And so in our example here, we are going to be using the Alexa skill kit as the trigger. So someone's going to talk to Alexa, and then it's going to trigger our Lambda function, and it will run. See, so we clicked, put it there. You can see they kind of have that built in. So, you know, you've got a blank box. You're like, you need something to add a trigger. And then you would click here, and then magically it would appear. All right. Configure the function, give it a name, and select a runtime, select Python 3.6 because just don't run Python 2 stuff. Let's see. Choose the existing role of Lambda basic execution. Hopefully you have that. I did get told that that's not. There's a link in the description that will help you set up your permissions. That's a little bit beyond the scope of this video. Review the screen and then click create function. So you can see I've created, oh, I misspelled it. It's, I don't know, monkey time. It was supposed to be monkey time on Python 3.6. Okay, now we have something important. You need to record your ARN, and that is this here. This here it is. I've scratched it off because you kind of want to, it doesn't need to be secret, but it should be. I'm not sure what terrible things could happen if you let it out, but someone probably could slam your service and then incur some charges. One nice thing about the AWS Lambda is it's super cheap. They give you like a whole bunch of like compute time for free, and but if someone had this, then maybe they could just attack your server or attack your function and cause you to incur charges. Bad things. We want to record this because we're going to need this later for our Alexa service. All right, now we are in the other phase of it. We're going to be actually creating an Alexa skill. So, and the link in the description, or if you already know where the developer console is, go there, click on the Alexa tab, and then click the Alexa skill kit. Sorry. However, I ran ahead of myself. Look at that. Okay, so now we will say click add new skill. Click add new skill right there. Once you go in there, you'll see that. Okay, now we want to name the skill and create invocation name. So in this example, we are going to be calling our little skill Dolly, and we've got the name here, and then the invocation name. And so as you heard earlier, there's invocation name is what people are going to say. So in our example here, what a user is going to say is, Alexa, ask Dolly for whatever, like what the temperature is. Although Alexa already does that, but that's a little bit redundant. But yes, so Dolly will be our invocation name. Click save and then click next. Okay, now we are in the launch the skill builder. Okay, so we've finished the skill information. Now we are in the skill builder, and this is where I have to be a little bit negative. The skill builder is in beta. You know, this stuff is a work in progress. It will do things that will make you angry. Stay cool. Everything will be okay. I wrote this thinking, oh, I bet somebody will have a problem with it because I've had a few in the past. And then immediately after making this tutorial, I was so angry. So just stay cool. If it doesn't work, it will work eventually. There's certain things where it has to build things for you, and sometimes those things hang. And if you just give it a little bit of time and just be patient with it, it will work out. Okay, so this is what it looks like when you're inside of that dashboard. Or I'm not sure, not the dashboard. It is the, what is the official name? The skill builder beta. So we can see some things that we've talked about earlier when I was talking about the big concepts. So we've got intent here, something that says intent, something that says about slot types. So we can kind of see where we're heading. We are going to create an intent. Right here, you can just click down here, add an intent, and then this will be the next screen. We are going to create an intent called favorite number intent. And just right down there and then click intent, click create intent. Okay, now we need to create an utterance. Remember we were talking about those, the intents, the utterances, and the slots. This is where they start coming together. So we're just going to have, I believe, one utterance, and that utterance is going to be, what is your favorite number? So essentially the use is going to be, Alexa, ask Dolly, what is your favorite number? That is what we would say to the little machine. Click save, build, then wait. This is the part where it can kind of freeze up or just be ornery sometimes. Once that's all done, click configuration. Once again, just be patient. It can be frustrating, but it's okay. Remember, this is amazing technology. Sometimes things are weird, and it is in beta right now. Okay, now we're at the point where, remember I said you wanted to save that ARN number. This is where we need it. We need to configure the endpoint. The endpoint is where Alexa is going to collect the information from the user and then send it to an endpoint and then get a response. So you're going to put that right down there. You're going to click AWS Lambda ARN and then paste that link down there. Click save and next. Testing. Okay, so it's not going to do anything because we haven't actually written any code or done anything, well, useful. So, but this is the testing simulator, so you can actually just type in an utterance here and then see what the response is. And what's cool is it actually shows you what the actual request was and what your response was. So you can kind of helps you debug some things, or if there's some, just debugging. We'll say debugging. Okay, so that is part 2, and I think we are still no questions. Hopefully everything's working out okay. I'm just gonna keep plowing through. So this video, for people who watch it later, it's not 3 hours long. All right, let's see if this will load. I'm trying to get, okay. All right, so we are now in part 3. Hello world, because that's what you always have to do, right? Everything has to always be hello world eventually. So let's talk about AWS Lambda. Oh, it's a big block of text. AWS Lambda is event-driven serverless, blah, 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 blah. It's probably different than most anything you've used before. You're going to be giving Amazon code, and they are going to be running it for you. And they're going to run it every time it's triggered. And that trigger could be, depending on the time of day, they could be based on a web request. It could be based on an Alexa skill. And that is what we're going to be doing. We want that Lambda code, or the code that we give AWS Lambda, to run and process a request and then give a response. It's pretty nice. I mean, I know that people poo-poo the serverless thing, but when you start playing with it, it's very interesting. I know I poo-pooed it. I mean, someone could probably look and see multiple tweets from me where I was very dismissive of the technology, but when you start playing with it, it's fun. Okay, so Alexa skill is going to be the trigger, and this will execute the code, and that code is going to process a request and then give a response, very similar to the way a web server would. Like if you're doing anything with like Flask, very similar. As a matter of fact, we will be covering this tutorial, but there's already a framework based on Flask for Alexa skills. It didn't work very well for me, but maybe it'll work for you. And if it does, tell me. Maybe I did something terribly wrong. Okay, so this tutorial is going to be using a helper template. This is where I kind of not cheat, but it'll help illustrate some things to you, maybe a little more. There's a link to this template in the video description below, so hopefully you find it. It's on GitHub. You can take it, you can do whatever you want with it. It's just going to make things a little bit easier for us. So let's take a look at the code. Okay, Lambda functions always start with a Lambda handler function, okay? So that little block of code you give it has to have this. Think of it like a main. A lot of other programs you may have encountered have this, where there's like one function that's going to be called, and you need to initialize it with it. So here we go. So it's going to get an event, it's going to get a context, and this is our first vision, our first encounter with these nested dictionaries. So we've got an event, and that event has a request inside of it, and that request has inside of it a type. And what we're looking for is the launch request. All right. So if we get that, we are going to call the onLaunch function and then pass it along the event and the context. And then we're going to return what that function returns. This function, its function is given two arguments, event and context. Event is a Python dictionary. See, Python dictionary, and then it's got another dictionary inside. Remember, JSON is everywhere. Almost everything you'll be dealing with is JSON. Those JSON objects will be represented by Python dictionaries. It's really important. I see a lot of people get really confused by it, so I'm trying to bring it up a bunch just so you don't get too confused. First, we check the event request type to see what kind of request we have received. Standard request types can be one of the three values, so you can have launch requests, intent request, and session end requests. All we care about right now is the launch request. Let's look at it one more time. See, that's all we care about. If launch request, then we're going to do something. We get anything else, we're not going to do anything. A launch request is sent when a user invokes the skill with an invocation name, but no intent. All right, how would that work? You might be wondering, how would that work? Alexa, open daily numerology. Alexa is a wake word, and then daily numerology is the name of our invocation name. Sorry, I got lost there myself. But there is no intent here, right? It's just a generic open. So that's what's going to happen is we're going to get, if somebody does that, we're just going to get the launch request. Back to full screen. So people, I don't know if it matters to anyone, but sorry. When we receive a launch request, we call onLaunch, and this is the onLaunch function. And we see my first helper function in that template, and that is statement. So we are going to return greetings and hello world. Well, what does that mean? Then this function, we see our first helper function, the statement function. Warning, we're going to go down a rabbit hole. You might need to watch this video a couple times, which is not going to be very useful for people watching live stream, but I don't think anybody's actually watching live stream, so that's okay. You might need to watch this video a couple times or back it up. I assure you it'll make sense. We're just going to go piece by piece, so it may seem strange at first, but once you see all the pieces, then maybe things will fit. Statement is a simple helper function that builds a response. So remember from earlier, an Alexa responds to a user with both a spoken output and a card output. All right, so let me just show you here what that statement's going to do. So it's going to build what we call a speechlet, and it has an output speech and then a card. And then we're going to end this session. We don't have to worry about how sessions work. We're just going to end the session because there's not going to be multiple interactions. It's just a one-time thing. We're just going to hand wave that way, and then we're going to build that response. This function, we create a dictionary. These dictionaries will be turned into JSON objects. We give the output speech the value returned by build plain speech, and we give the card the value that's returned by the simple build card. I'll take a look at that one more time. So here we've got the key output speech, then we build it. We got the card, and then we build it. Don't worry, we're going to get into it. This is the rabbit hole I talked about. When we give that dictionary to build response, then we give that, I can't read, I'm jumping ahead in my mind already. When we give that dictionary to build response, it'll return. Then we give that dictionary to build response and return the result. I didn't need to go backwards. That's what threw me off. This isn't new code. This is the same code from before. Okay, this is what we're building. Remember this? We saw this earlier. This is the response. This is what we're building. So you can see here we've got a card, and they got a speechlet response, an output speech. Okay. Let's deconstruct some of the other helper functions that this that statement called. So we've got build plain speech, we've got build simple card, and we've got build response. Let's look into those more deeply. Build plain speech. It's pretty simple. Once again, we're just building. These functions are pretty simplistic. They're just building dictionaries. So this is going to be, this response is just going to be in plain text. There are different, yes, I won't confuse you. Just don't worry about, there are other types of speech you can return. But right now, what we're going to care about is plain text and then the body. All right. So we're going to give it a body, and that body is actually what the Alexa device is going to say in response. And then we turn it. Simple card. Simple card is that little graphical interface. It's just got a title and a body. And once again, there's multiple types, but all we're going to do is the most simple one, and which is called simple. And we're just going to make a little dictionary. It's got, you know, a title and a body and a type and return it. See, it's very simple, even though, you know, it seemed a little magical. Hopefully this works for you. And then build response. We got a little bit of boilerplate here. We need to put what the version is, session attributes. Don't worry about those right now. And the response. Alexa will say out loud, "Hello world," and it will create a graphical card titled "Greetings" with a body of "Hello world." You see, just by using statement, and then we give a title and then the body. So Alexa is going to say the body, and it's going to make a card with "Greetings" as the title, and then "Hello world" as the body. Hopefully that made sense. I tried breaking apart as much as possible, so hopefully you are you're on board with that. We're at the a new video. I tried making this all one slide, and it failed miserably. If you ever make like a really big Reveal.js document, nothing against Reveal.js. I made too many mistakes and it fell apart. Okay, so we are now in part 4. I think we're halfway done. Handling intents. Okay, so we're going to add another if statement to our Lambda handler function. Remember we said there's like 3 or 4 different kinds of types of requests. So this time we are interested in intent requests because that's what we're doing right now. We are handling intents. So basically the same exact thing. but we are going to be doing something a little bit different. We are actually going to be creating another function called intent router. Now you can have a lot of different intents. And so what we want to do is have one function that kind of can route them around. And we don't want to shove them all into this Lambda handler. That'd be kind of sloppy. So this looks kind of nice. And as we go, this is going to grow and it's not going to look nearly as nice as it looks now. But if we put like an intent router in here, it would start looking pretty ugly. So we continue to check the event request type to see what type of request we have received. And now we're looking for the intent request. An intent request is sent when the user invokes a skill with an invocation name and an intent. Okay, so Alexa, ask daily numerology, what is your favorite number? Okay, so we have already made a favorite number intent earlier in part 2. Do you remember that? Yeah. What is your favorite number? We did that. Hopefully. I mean, we didn't actually do that. This is just slides, but you probably didn't follow along. I hope you weren't following along. It'd be so hard to follow along, moving so fast. We'll create an intent router. It will route the right intent to the right function. So we have created here a new function called intent router, and it's going to take an event and a context, and it's going to have eventually it's going to have a series of if statements. So that way it will be able to tell, because if you look, and this is where I said what we're going to do is this is a dictionary. What's a dictionary within a dictionary? So we're starting to get those nested dictionaries where it gets hard to read. Like that's a very long variable name. So for readability here, I'm just going to assign that to intent, just so it's nice and easy for us. So that, first of all, keep that in mind. I'm just assigning this to intent for readability. You don't have to do that, but this is a very long variable name and it could be very hard to read. Okay, so now if intent equals favorite number intent, then we're going to call favorite number intent function, right? That seems reasonable. So, that's it. Yeah, so I'm assigning it for readability. Those nested dictionaries to get hard to read. The intent router will send favorite number intent to the function that I already covered. Once again, I'm stepping over my own slides. I need to mellow out. Okay, so now we're going to create the favorite number intent. This favorite number intent is super simple. Dolly only has one favorite number, and that is number 13. So she's just going to say my favorite number is 13. So remember how our interaction with Alexa was going to be? We're going to say, let's see if I can remember. Alexa, ask Dolly, what is your favorite number? And then Dolly is going to respond by saying, my favorite number is 13. And we're using that statement function that we saw from earlier to make it nice and simple. You can see how easy it is. It makes it very nice. Oh, hey, that's the end. That was handling intents. So you just have to remember that you have this intent, this request intent name, and that's going to tell you which one of your intents you have just received. And then you can decide what you're going to do with it. All right, let's see. Let me get out of here. All right. We're going into part 5 now. Ooh, part 5. Okay, so part 5 is, required intents. Yes, yeah, the required built-in intents. So let's see. I'll pause so I don't. In addition to the custom intents, there are also required intents. All right, Amazon. There's a cancel intent, help intent, and a stop intent. Your skill will need to implement these before being approved by Amazon. So you can mess around doing your own thing, but I believe all those things are now required in order to get approved and be into the store. So we're just going to add some boilerplate things. So you can see how I said that that beautiful intent router was going to start to get ugly. And yeah, so now we've actually, yes. So yes. These are going to be placeholders. I think they're pretty self-explanatory. So the cancel intent, the help intent, and the stop intent. So each one's going to, this would probably, I mean, if any human saw this at Amazon, I don't know if they look at this stuff, but this is totally unacceptable. So if you tell it to cancel, it's going to be like, hey, you want to cancel? You want help? It's like, you want help. The worst help system ever. And you want to stop. That's it. Those are the built-in intents. Granted, if you are doing a real skill, these will have to be much more robust. But I just wanted to let you know because I did see some people on one of my chats, and they wanted to know why their skill had been rejected, and apparently they needed some of these. So, and it's yeah, I will keep my keep some comments to myself. Okay, so that was it. That was part 5. Now we're going to go into part 6. All right, part 6. Oh yes, wait. Here we go. I know this part's the most exciting part of the entire video. Okay, how to make an Alexa skill. Part 6. Handling slots. Slots are like variables. Remember we talked about slots in part 1. Let's create a slot in the skill builder. Okay, we're going to create a new intent called lucky number intent. Boom, lucky number intent, just like how we made it before. This time we're going to make a slot. So we're going to say is, and remember we talked about it like this being kind of like Mad Libs, right? Is blank lucky? And then that blank is going to be numbers and 2 brackets. Notice those brackets? Let's go back. See? Brackets. That knows that those are kind of like the Mad Lib portion, that this is going to be essentially blank. All right. So is blank lucky? And what we want is a number. And that Alexa actually helps us with that because you can actually assign the slot a type. You can assign the slot a type. It is not, how can I say this? It's not going to force it. So you could still say, is pony lucky, and it'll return it. But it, from what I've been told and what I believe, is that it helps Alexa sometimes maybe differentiate. It gives it context. So maybe it thought it heard pony, but then it thought it may have also heard 13. I don't know how it happened. I should have came up with a better example, but I did not. So anyhow, you go in here, off to the side, you're going to say intent slots, and then you're going to try to select it. So just put an Amazon number, and that's going to work out just fine for you. So add a new intent to the intent router. We're going to, underneath this, in order to clean this up so it's not like a huge block of code, we have down here those required intents, but we're just going to ignore those for right now. So if intent equals lucky number intent, we're going to call the lucky number function, just like we've been doing. So this should be pretty straightforward. Hopefully you got it. This is where it gets a little more interesting. So this is a little sample of what is inside of that intent JSON. So it tells you the name, which we've been dealing with. We've been checking what the names are and then, dealing with that. But then there's actually a little place here called slots, right? Slots got a number, and it's got a name, and it's got a value. So what we're looking for is a slot called number. Sorry about that. Hopefully, I'm too much talking. Okay, so a lucky number intent. This function tells us the skill's favorite number. No, that is wrong. I am so sorry about that. This function tells us. I mean, it's partially true. Our little Dolly skill is very opinionated. Not only does she think that that 13 is her favorite number, it's the only number she thinks is lucky. So when we ask Dolly, we say, Alexa, ask Dolly, is number 13 lucky? She's going to say yes. Any other number, she's going to say no. All right, so what we're going to do is we are, once again, just for readability, we're going to dig in here. So an event, there's requests, then intent, then slots, as we saw earlier. And then we're going to put that into a variable called slots. And then we're going to access inside there number, value, and then get the value in there. So if we look, boom, that's what we're going for. Intent, slots, number, value. That's why I was talking about those nested dictionaries. So, they get monstrous. So, and this is very simple. So it's just going to be checking a case, and it is important to remember that even though you told Alexa over a few that it was a number, it's still returning it as a string. Maybe hang up for some people. So it's going to make a card with the title that says lucky and a body says yes, and then it's going to just say yes or no in the spoken part. Gotta love those nested dictionaries. You can imagine if this was, so this is slots, right? And then this would be the next layer down. So you actually have like what, four nested dictionaries deep. So that's why I have assigned them to other variables for readability and just for sanity. All right. So we've completed another one. Oh, wow. Okay. I wonder how long have we been going? I don't even know. So we're going to go to number 7, part 7 loads, and we're going to go full screen again. Okay. Now we are in part 7, handling sessions. Do you remember how sessions worked? Do you remember sessions? If you remember from part 1, sessions are a series of interactions with a shared memory, almost like a session cookie in a web browser. Let's create a new intent in Skill Builder. This new intent is going to be called counter intent. We're going to create a couple of utterances. We're going to create one. They're kind of grayed out here. You're going to create counter and then start counter. And we're going to add the intent to our intent router. You can see down here. So we created a counter intent, and then we're going to create a function to handle that counter intent. See how that intent router works? That way we can put them all in here, and basically its entire job is to route the intent. It's almost as if it was well designed. Create the counter intent function. Here we go. Okay, now we're going to get into something a little bit more different. More different? Okay. All right. So what we are going to do here is we want to, once again, for readability, we are going to be putting in the session attributes dictionary, and we're going to put that into a variable just called session attributes just for sanity. So we're going to check to see if inside of that dictionary, if there is a key called session attributes. And if so, we're going to increment it. And if not, we are going to create one and make it 1. And then we're going to use a new function called conversation, and we're going to give it that information. It's important that you make sure you keep passing around this session attribute because it will forget things very easily. This function introduces the session object and the template helper function conversation. It's important to remember these template functions are not built into the Alexa stuff. This is just my helper template where I was trying to break things down. You're free. You're more than willing. I don't know if you're willing to or not. You're more than free to use that code, reuse that code. I think I just put it like under the MIT license. I mean, it's not. Yeah, it's mostly for education. The session allows us to store key value pairs inside of this dictionary that is inside event session attributes. These key value pairs disappear at the end of the session. It's important to remember that. If I interact with Alexa and the Dolly skill, and then I come back to it later, it's going to forget about it. As long as I keep on interacting with it back and forth, it'll be there. In this function, we are incrementing a counter in the session and returning the result of the template's conversation function. Let's go into it. Here we go. We saw it earlier. Okay, now let's look at that conversation function. All right, it's going to be very similar to this statement function, but you see how this helper template has things kind of structured. There are statements where Alexa is just going to say something and it'll be done, and a conversation where maybe there's more interaction, like you're having a conversation. So the structure is going to be almost the same as statement, except this time we are using those session attributes. With statement, we didn't care about session attributes because there was no real session. This time, the session is held. Okay. And then we're also going to say end session is false. Remember with statement, we said we were ending the session. So we put that as true, false. The session is going to stay alive. So our first interaction, when we say, Alexa, ask Dolly to start counting, she's going to say 1. There we go. she's going to say 1, and then the user, that session is going to still be open. And then the user says count, and then Alexa's going to say 2. You're just going to say count. And Alexa, oh, hopefully she doesn't. Hopefully it still increments. My little note here is wrong, but she's going to say 3. And so every time you say count from that code earlier, we are going to increment session value. And then it's going to tell you what that value was until you end. And so you could say Alexa stop or Alexa cancel. So that is session. So you can store these key value pairs. And also it shows you if you make the session end, should session end be false, Alexa's going to keep your skill open essentially and then wait for another interaction. Okay, so we have reached the end of that one. Oh, we're getting close. We're getting close. All right. We are in part 8. Handling dialogues. All right. Dialogues help the collection of multi-part data by asking for follow-up questions. So let's create a new intent with a skill builder. We create a new intent called trip intent and a couple of utterances, one of which has a slot called toCity. You'll probably see the same kind of structure used in a whole bunch of places. I liked it, so I just figured out just do what they did. Okay, so you can see we've made the trip intent. I kind of skipped a screen because we've done this a couple times now, so I figure you don't need to see it again. So we made the trip intent, and then we've got these 2 utterances here. I'm going on a trip, and I'm going on a trip to blank. And that blank, we're going to call it toCity. And we are going to say that this slot is required. I don't have enough room on my screen, but if you were to scroll down, you can see actually right here. Does this intent require confirmation? It's got a yes or no. We're going to click yes. And then we're going to have a prompt, right? So if that slot here, toCity is not found, and that would happen if I just said, I'm going on a trip. It's going to ask a follow-up question, and you can have these prompts be whatever you would like. And this one, I'm going to say, what city? And then it's going to say what you expect back. And I expect a city back. So the kind of example would be, I say, Alexa, tell Dolly I'm going on a trip. And then Dolly's going to say, what city? And I'm going to say, Portland. Everyone uses this example. I should have come up with a unique one, but I didn't. That is what it is. So, but if I was to say, Alexa, tell Dolly I'm going on a trip to Spokane. See, like I changed it up there. Then there won't be a follow-up because that slot has been fulfilled. Hopefully that makes sense. So that's how these dialogues work, right? It's like we know we want this set of information, and we build these dialogues to help us get that information from the user. It's very good for certain things. Like if you do have like the multi-part questions, it's hard to imagine, or it's going to be very hard to train the users to have answer like 3. Like if you have a utterance that has like 3 slots in it, it might be hard to get the user to actually say sentences in that structure. It'd be way easier to go to these simple sentences and then do follow-up questions. Try to make it as simple as possible for you users. So we're going to go to the intent router. Oh, we may have ran out of room here. We're going to go to that intent router we built earlier, and now we are going to make a trip intent. I bet you could have guessed what we were going to do, and you were probably right. And here is the trip intent. Okay, so we are going to dig into that event. We're going to find the dialog state, and then we're going to assign it to a variable. Once again, readability. We don't need to, but it helps in readability. Okay, so one thing with these, well, oh wait, the wonders of live video. Yes, so we're going to check inside that dialog state or we're going to check the dialog state, right? So we assign the dialog state to the variable dialog state, right? We're going to check inside to see if it's either started or in progress. We are going to continue the dialogue. Okay. Else, we are going to, else if we're going to check to see if it was completed. And if it is completed, we're going to say, have a good trip. So what does this mean? It's going to return completed when all those slots are full. When all the slots that you told it were required are satisfied, then it will send a complete. If it was the very first time, it's going to, if it was the very first interaction, it's going to send started. And if it was somewhere in the middle, it's going to send in progress. We only have one intent. And so we're just putting those both in there just for easiness. And then we're going to be returning the result of the function continue dialog. This function uses the dialog model. Dialog model helps the collection of multi-part data by asking follow-up questions. We need to return this. This always gets me out. My last video, I had a hard time. We need to return a delegate directive to continue the dialogue. And I'll say it again. It sounds like something from Star Trek. The delegate directive. Yeah. Okay. So first we check the dialog state, which I showed you. If it's started or in progress, we call it the continue dialog function. And if it's complete, we have access to the information in the slots. So here we go. That was it. So we probably are wondering, or you probably are wondering, I was wondering, you were wondering, that continue dialog, that's another helper one, or helper function from that template. We could have put all this information in that function, but it's nice to pull things out and don't repeat yourself. So here's a continue dialog. We're going to make a little dictionary. We are going to say, should the session end? False, right? Because we want to continue interacting with the user. So it's false, right? So as we saw in this code, it's going to return that if it's in progress or started. And that obviously means that it's not done. So we got to keep on going. Okay. And then this is kind of a boilerplate code here for us right now, this use. We are just going to return this type dialog delegate. And then we're going to build a response. And that might be it. Let's see. I think there was a part 9. I think I was working on a part 9, but then I decided that wasn't necessary. Let's see. No, there's another part 8. Thank you for watching this video. If you have any questions or comments, please leave them in the comments below. If you like this video, please, hit that like button and subscribe. And if you want to see me do more live streaming stuff, tell me about that too. I'm not sure. And this was also a rather long video. I'm very curious what you think. So yeah, give me your feedback. Thank you. And thanks for taking the time to watch this video. And I hope you make something wonderful with Alexa and keep using Python. Goodbye.